Hello, Sean. Hello,
Awesome.
hello, hello. Hello, can you hear
Yep,
me?
I hear you well. Sounds good.
Okay, okay, awesome.
Hey Tonga. So Ravi, do you want to go jump in the tech labs? There's the link to the Notion. Do you have that open?
Where is the link?
In the
In
tech
the
tech labs channel.
Tech Labs channel. Yeah.
Hey Bao, nice to see you.
Control C. Firefox. Focus. Control A. Has simulation lab 3. Okay,
I
go
guess I was
continue.
muted. Okay.
Hey Bao.
Hello. Good to be back.
Bao, your mic is a little bit robotic. You maybe try rejoining the call. See if that helps.
You know, it turns out it's my headphones.
There you
Every
go.
time
That
I
is
use
so
them.
crystal clear.
Awesome.
It's your headphones.
Yeah, I always get that. I sound robotic. I have these the Bose 700 noise canceling headphones,
Mm-hmm.
and sometimes they work and sometimes
Mm, interesting.
yeah, I'm not sure what's going on.
What did you just replug them, or did you switch to a different mic?
I just switched to my inline mic in my computer.
So I guess it's the sound canceling aspect that might be making things wonky.
Hmm, that is actually probably right. Try this out again.
Hey Sam, nice to have you here. Oh, Santi, great. Good. So everyone can get started in the Tech Labs channel. So go ahead and open up that Notion page. And you're going to see the first link in there is going to bring you to a spreadsheet. And if you haven't joined one of the labs before, then go ahead and add your name, your operating system, Discord tag, Telegram group, Telegram tag, and Twitter handle. Everything's optional. This is like voluntary data entry, so anything you don't want to enter, you don't have to. Hey, Lansky.
Hello.
Nice to see you. So yeah, everyone can get started and just hop in the Notion that's linked in the Tech Lab, and then go ahead and open up the spreadsheet. And just to show you're paying attention, go ahead and put an emoji in there of your choice. So I always go to getemoji.com. I find it to be a really quick solution. Awesome. Nice. So I'm really hoping that Griff joins this, because the point of this lab is essentially to be picking Griff's brain. I want to be able to find every resource that he knows is available for anything that's any sort of modeling that's been done on any components of the hatch. And so he listed a few of those off to me earlier this week in a call. So I'm sure, I think between everyone here, even if Griff doesn't arrive, I think between our collective brain powers, we should be able to track down a lot of resources. But hopefully he hops in here. Maybe I'll send him a message.
I just pinged him too.
Awesome. Hey, Sebnum. Oh, she just dropped. Hey, Sebnum. Maybe she's in another call or something. So I guess we'll give it. It's already 6 minutes after, so we'll probably get started soon. Hey, Livy.
Hello.
Hey, nice to see you here. So go ahead and hop in the Notion, open up the Notion page that was linked in the Tech Lab. Maybe you have already, but that'll bring you to the data sheet for the week, Lab 3. And go ahead and open that up. So there's assignment number 1 is to post an emoji in the spreadsheet
Oh,
there.
cool. That I can do.
Does everyone have their coffee or tea or water? Very important for the lab.
Wow, really just said that as I was picking up my coffee that I haven't taken a sip of yet.
Oh,
Oh, I'm robotic again.
yeah,
Shit.
that first sip of coffee.
We have a. I apologize for that. I put my headphones back on and thought I would give it another shot.
Nice, yeah, it's crystal clear now.
Beautiful.
I have coffee. It look like, yes, I have my coffee here, but I cannot drink it because I'm a rock.
What'd you say, Sam? You're out of what, cream?
It looked like a robot was saying that I have my coffee here, but I cannot drink it because I am a robot.
That's awesome. Okay, I think we should get started. Um, okay, I think this is the crew, but I'm sure we'll have a few more stragglers join in. So, good, we got some good emojis going, so everyone's in the data sheet. So, the point of this call, for those who just joined, or this lab, is to essentially do a blitzkrieg, as I called it, but to find all of the resources that we can on all the components related to the hatch that have already been modeled. So any sort of modeling that's already been done. And if Griff jumps in here, he'll be able to point us in a lot of good directions. But if not, that's okay. I got a few leads from him already. He mentioned the Luniswarm hatch is something to look into. He mentioned find the augmented bonding curve modeling from Zargum, and he said there's some conviction voting modeling. And then I know also we've just recently been putting together the commons simulator, and I'm pretty sure there's a model in the back end there. I'm not sure if maybe that's the Luniswarm or different. No, I think it must be different. And then additionally, we have some impact hours modeling and the source cred modeling. So those we can get into as well. And I do have the links. So what we're going to do, I've got the Notion page going, and we're going to build this out together so we can all collectively simultaneously like find these resources and link them in here. And once we start finding where they are, then we can start going through actually cloning the repos and running them locally. And we can do this pretty much all simultaneously or asynchronously. And I'll be, if you want in this lab, if you do want to just kind of sit back and watch, because I'm going to try to go through this stuff really quick. But also, I want to source everyone's help, especially in just finding resources. So if anyone can like dump any resources they know about, and then also we can go on this kind of Easter egg hunt together to track all these down. So my plan is to kind of jump in and start driving, but you guys can like shout out stuff to me if you have tricks or if you know where some of this stuff is in particular. And yeah, and then anything else that you think we should cover, just shout it out and we can all collectively build out this Notion page. Nice, I see the conviction voting coming in. That is awesome. And so I guess there's two tracks here. There's one is like finding all the resources, and number two is actually running them. So let's spend a little bit of time tracking down resources. And so in the cells here, let's put a 1 if you've opened up the resource and a 2 if you get it running locally. Okay, awesome. So I'm gonna, let's see. So we have conviction voting coming in. I'm gonna make that, so let's open that up. Oh, this looks awesome. Aragon conviction voting.
Maybe we need a title for conviction voting things.
Yeah.
I still don't know how it works.
Are you new to
Okay.
Notion?
Not really, but never worked for me.
Oh. Okay. Ravi's got his name in there. That's good. GitHub name? Oh, yeah. So GitHub name might be an interesting column here. That might come in handy. Can someone add, can someone on the fly add a extra column in the datasheet for GitHub handles? And I'm gonna try to track down this Luna Swarm repository. Luna Swarm. Oh, is it one hive? Oh, okay.
Yeah, I'm not sure what it's about, but the Luna Swarm is like the Garden Swarm, but for modeling. And at least the meeting I went, they were modeling one hive conviction voting with the liquidity on HoneySwap, something like that. It was very specific for one hive.
Oh, it's interesting because Griff told me that that would be a really good resource to look at for the modeling. Maybe it's just a good example of using CAD. Here's the conviction
Hmm.
voting CAD. Oh, okay, yep, that's the one from One Hive. That's great. Let's see who we got in the call here. Yep, same crew. Okay, so what else? So I'm not sure what Griff meant by the Luna Swarm. Does anyone know where the augmented bonding curve modeling is by Zargum?
Yes, it is in block science, GitHub.
Oh, yeah.
It is another one. The newer one is the one that it's said that it's already in the document.
Oh, nice.
But the new one is only for conviction voting, and the old one is conviction voting plus bonding curve.
Okay, should we
Okay.
Do
um
you want to put more resources or only
yeah,
GitHub?
any sort of modeling that it would be relevant to the tech hatch. I think we should compile
So
here.
the bonding curve is inside conviction voting or where? I don't think so.
We have
Because
been using,
I don't see where to put the link of, for example, a Medium article about bonding curve.
Hey, yeah, you can link Medium articles too. How about that? That's a good idea. Under the sections that they cover. Okay. Oh yeah, this is what I was wondering. Sem might know. The Common Simulator game that's been launched. I think it has a CAD model in the back end that's returning the simulation results.
yes,
Does anyone know where that's accessible from?
it's in Common Stack. We have many different organizations. One is in One Hive, another one is in Block Science, and the last one is in Common Stack organization.
Okay, I'm gonna look for the one in Commons, in the tech. So,
I think it is Common Simulator. And the thing is that it has some front end, and the folder with simulation is the one that contains the simulation.
so I'm not seeing it in the Token Engineering Commons.
No, it's not in Token Engineering Commons. It's in Commons Stack.
Oh.
I have the link and I am just publishing it here. I don't know how to make that a nice card.
Oh, you just once you paste a link, it should have a little pop-up with options, and the one is its bookmark.
I don't know how to do that.
So do you see my screen?
Let me see. Okay.
So after I paste, I get
Okay.
this pop-up.
Okay. 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 Then you can remove mine.
Okay, this will be a nice one to open up.
Basically, Common Simulator is an iteration over conviction. So we based the Common Simulator on the conviction modeling. Actually, inside conviction, there are three models, and we are using the latest one, which is the third. And it's a bit convoluted, but if you can see, there is a conviction cat 3, which I think it's the best introduction to what we have on conviction. Well, actually not. Conviction voting, the best thing is the one hive. It's made by block science, but we transferred it to one hive, and it's the best one right now because that's the one.
Okay, let's take a look at this one.
For conviction voting, that's the best one. And then the just conviction, it uses the augmented bonding curve.
Okay, sweet. We've got some notebooks, so I'm gonna open those up. So, Aragon conviction voting. Awesome. So let's see, they added the realism that not all participant tokens are being allocated to proposals at each time step, refactored parameters and system initialization to make more readable and consistent, changed file structure and file names to align with emerging CAD/CAD standards, making the distinction between effective and total supply, refining alpha calculations to more accurately reflect the one hive implementation, discussion of alpha and its relation to alpha in the contract and how it relates to the time scales, moved all unit denominations to honey, the one hive governance token, added system health metrics. Okay, this seems like a good resource. So
It's the changelog version 3, but you have the other versions in that same repo. I think, yeah, we have three notebooks. And for example, if we want to talk about the parameters, alpha is one of the parameters. And then we have the how much conviction do we need in order thr- um,
oh, the
to
trigger
trigger a
function.
proposal? Yeah.
So the y at t of j must be greater than yt star of j.
Basically, it's a function in which you need that amount of conviction based on some parameters
Okay,
to
so we have the total
get the function.
supply of honey, or in our case, TEC tokens, right? And we have the
Yeah.
effective supply equals E, so I guess that's just like a subset of S. And oh, it's honey committed towards votes, whether proposals are abstaining. There's the funding pool F, community funding pool, where proposals are funded from. So I don't see F in this diagram, but that's okay. Other supply equals L, the effective slack. Funds could be in cold storage, in liquidity pools, or otherwise in any address not actively participating in conviction voting. So the total supply is equal to the funding pool plus the effective supply plus the slack. Okay, sweet.
Mhm.
So the system has the right to do direct mints. So we can create more tokens. in the funding supply or in the total supply. Or really just in the funding supply, I think. Oh, wait. Oh, no, yeah, because if we
Yeah.
add more to the
We are
funding supply, then obviously that's adding more to the total supply. Um,
and we are modeling probably we are modeling one hive's template, which basically it's creating new tokens, new honey tokens each block. And we are not going to be creating new tech tokens each block, but we also have the bonding curve, which allows us to burn and mint tokens. If that
so
has
is
sense.
there no bonding curve in this case with one hive?
There is not. It's an issuance policy that creates new honey and it goes directly to the funding pool. It's a simpler model.
Okay, so I'm gonna just check in with everyone to see who can follow along if you want to jump in. So this notebook definitely looks super juicy. So this was um, let's see, which one is this? Well, is this
That's the
even,
conviction voting.
it's not even linked, is it?
Yes, it is. In conviction voting. The conviction
Not
voting
from
card,
block science. It's from, let's see, wasn't it from One Hive?
it's in one hive.
Okay, it's this
It's
one.
in one hive, but it's originally from block science. Most of it is from block science, but we transferred it.
Oh, it's here. Yes, yes, yes. The first one on
Yeah,
conviction voting. Okay, so yeah, I'll just take a moment here. So for anyone following along that wants to jump in, I would definitely recommend it. So open up this GitHub link here, the OneHive conviction voting CAD. Go ahead and clone that repo. Clone that repo onto your local file system. And then as soon as you clone that repo, you can activate your virtual environment if you use virtual environments. Or if you install your Python libraries system-wide, then you don't have to worry about virtual environments. And if you're like, what's a virtual environment? Then you're probably not using one, or you're using Anaconda, in which case this is all handled for you. Oh yeah, no, actually you create virtual environments through Anaconda, so I think that's important to know. And all of this is covered in the
Sean, I
first.
have one question.
Yeah, I'll just finish. So that
Sorry.
what I was just saying about virtual
Sorry, yeah.
environments, if that's totally over anyone's head in this call, then definitely check out the CAD course because it's covered in the first couple topics. Yep, Sebnum. Questions? You're muted.
It's okay now. Yeah, I know. I was clicking on it madly. So basically, do you that like now you're going through this as an exercise, right? So did you, because I came late, did you find everything you need for or we need for hatch parameters, the augmented bonding curve? In this Notion, you will have everything.
Well, hopefully, but we have to really actually go through it to know. So that's why I'm really
Okay,
excited about this notebook. This is the one I'm going to share in
you're
particular.
going in.
Yeah, because Sam mentioned that this one is probably the most up to date, and then when I see it, it's like, wow, this is really well written, and I mean, so far I feel like I'm understanding it
Yeah,
well.
yeah,
So I think it's a good place to
perfect.
start.
So I need to jump off, but yeah, can you share the Notion link as well? And if you find anything, whether it will be next week or when, if you can figure out that information, like
Yeah, so
when
I'm
we can
hoping
help
that
with the parameter simulation.
given this introductory lab, I hope it gives everyone the confidence to go and open up all these
Mhm.
simulations, and then we can have some collective intelligence of what we might be missing. And
Okay,
we'll
cool.
follow up with that next week. But
Okay,
I'll
cool.
reach out to you if there's
Perfect.
anything in particular.
Okay, have fun. Thanks a lot.
Thank you. Have fun. So, yeah. So I'm gonna fill in my data here.
Hey, so I've set up a virtual environment in Windows. I haven't done it in Mac OS, and I have a Mac now. I'm just wondering, do you guys know the commands to set that up?
Yes. So,
Awesome.
do you have pip going?
I will check.
Yeah, just actually first do this. Type Python space dash dash version.
Mhm.
Hummus.
Hey, Sean, I'm getting in here late. Where's the links to all this stuff?
Yep, I'm glad you asked. Is that Blair? Oh yeah.
Yep.
Awesome. So yeah, go ahead and check out the Tech Labs channel in TE Commons, and
Okay.
it's just that Notion page there.
Ah,
And
cool.
yeah, and then that'll from there you can open up this data sheet.
How do I change which version of Python I'm running? Do I just type Python 3 if I have it installed?
Yeah, if Python gives you Python 2.7, then you're gonna want to use Python 3 everywhere.
Right. Yeah, that's what happened. But let's see. I have 3.86 installed. I'm pretty sure I have 3.7 installed too, which is complicating.
Well, those are all. If you're using any of those, they're all good.
Okay.
Basically, anything 3.6 or later is good, but yeah, 3.8 is ideal.
And if you're new to Python, just use Conda.
Yep. Or be a legit hacker and do everything on the command line.
That's what I'm attempting to do. I'm having to learn Python for work anyway, so it's like this is probably better I do it this way. That's at least how they want me to do it.
Yeah,
Python with Pan.
it kind of opens it up more. You get to see what's behind the scenes, and then especially if you're on Mac, then using being somewhat comfortable with the terminal will go a long way and will help
Yeah,
kind of troubleshoot down the road.
I was using PowerShell with Windows, and that was a huge pain in the
It's a
ass to
nightmare.
get virtual environment set up because after a while I found out that I can't actually do certain things inside of PowerShell. Like I couldn't check if I was actually running a virtual environment or not. But then when I went into the normal command prompt, I was able to check that, and I was like, "Oh my god,
Yeah.
this would have saved me so much time, like researching and whatnot."
So when you get a chance, if you want to play around and upgrade your shell experience, go ahead and install Fish Shell and use that. It comes with so much niceties out of the box, like auto completes and recommendations and extra tab completes and color coding and things like that. It's a really good shell, and it'll help down the road. Yeah. So with virtual environments, you want to go probably pip3 install virtual env, all one word, virtual env.
So here's the deal. When I typed in Python 3, it spat out, you're running Python 3.86, blah, blah, blah. And then now I can't type any other commands after that for some reason.
Try Command D or Command C. That should, or you might be in the Python shell now. So you gotta quit out of it.
That is yeah, I am in the Python shell.
Yep. So you can type quit and then parentheses.
Okay. Right. Yeah, I'm sorry, man. I'm forgetting all these commands right now.
Yeah,
It's
yeah.
not
That's why you gotta get the fish shell. It's like your external brain in the command line. But that's for
cool.
later. For now, you'll get these.
Now I
Yes.
typed in Python version again, and it gave me 2.7.
Yeah. So
How
Python
do I?
3. You want Python 3,
Right.
and then you're gonna use pip3 install virtual env.
Yeah, yeah, the end. Okay.
And then once you have that installed, I'll write these commands in the spreadsheet here.
sorry for being behind, guys.
That's okay. Everyone else is probably reading the resources or cloning the repo. I'm sure. Okay, so, or yeah, and we can all fill in the data set as you go, because I got this. Oh, I'm putting links in here now. So I'll put links at the bottom, like here. And so the idea with this spreadsheet, you guys, is like if you're able to find one of these resources, go ahead and put a 1 in your row. And if you actually get the resource running locally, then put a 2. So I got this conviction voting running, so I'm going to put a 2 there. I've definitely found the source cred links and the impact hours. I got those running. Okay. So where's that common simulator? I think we found that one. Here. Oh, is the model in this repo? Oh yeah, simulation. Awesome. Random Shinichi, so good.
I added an article about the augmented bonding curve, but I don't know where in which column on the Excel sheet should I write.
So if you want to post links in the Excel sheet, go ahead and just fill up. So find the column. So is it on the augmented bonding curve? So, and then you see I made this row for like links. And then you can just make more rows. So, oh, it can go here.
Okay, I have put it in the Notion doc because yeah.
That's awesome.
Okay.
Oh yeah, that's super helpful. So I would recommend everyone to try to get the OneHive conviction voting CAD simulation running. I'm gonna keep stepping through that. So here's the parameters. Initial values are the starting values for the simulation. So we're setting sentiment to 0.6, N equals 30, M equals 70, funds are 4,867, supply is 2,000 or 22,000. So I wonder if these are randomly generated or fixed. Oh, configs. Is there a config file? Config.py. So we initialize n to 1, m to params. Where does params come from?
That's all, cat. I'm not sure. I'm not sure. I'm sorry.
Oh, that's okay. Thanks for. I think you were trying. Oh, so it looks like they're supporting or sorry, importing from this cat. Oh no, dot parts. Oh, okay, dot parts. And then they have sysparams.py. Cool. This is awesome. We found the golden. It's all the parameters that they input by default. So this is essentially the goal of what we're trying to accomplish right now with the TEC community, is to identify all of these parameters.
Okay. Actually, I know more or less what each parameter is, and for example, there are parameters that are part of the simulation but are not part of the conviction voting or anything in the system. Sentiment, for example, is the sentiment of participants itself, because as we are modeling participants, we are assigning a sentiment from 0 to 1, how likely they are, how much they love the community, and the initial sentiment is 0.5. We also have an initial amount of 30 participants, or we probably they are going to be the hatchers or something like that, and a certain amount of initial proposals, which is 7. But the participants and the proposals are going to grow over time. We also have an initial amount of funds and an initial supply of tokens. In that case, is honey.
Mm.
And then the other parameters, beta, rho, alpha, gamma. The three first ones are conviction voting parameters.
Mm.
And gamma is okay. That's the inflation of honey.
Mm. Cool.
And we will remove that and add a conviction voting, I guess.
Hey, you mean separate these? What do you mean? I think you said remove that and add conviction
No,
voting.
no, no. I mean, this is for honey, which they are using an inflation policy, that gamma here, but we are not going to have an inflation. We are going to have a bonding curve, so we are not going to use gamma. Well, it's interesting to have gamma here and study how conviction vote, how one hive works, but there is also the other model in which we have a bonding curve, which is not actually the bonding curve that we have right now. So there is plenty of space to create new parts of the model in which instead of having a gamma, we have a bonding curve with the parameters of the bonding curve and how it works. And we have many other parameters there that I don't know, but probably you can read by your own.
I'm gonna post a screenshot of
And
this.
yeah, it's a complex model because we are simulating people. We are simulating how people like proposals and
Yeah, I think the more the I think the model has a lot of room to grow in its complexity. And I know there's in data science there's always reference to Occam's razor. It's like the simplest model it tends to be the best model. But I think in the case of these crypto economic systems and especially when we're combining these different components like the bonding curve, um, and all the other components. It really is complex in its nature, and so in order to match that in the simulation has to grow with quite a bit of complexity. So, like as I'm seeing this, this is so beautiful, but I know that there's so many uh, there's a lot of depth that could be expanded into this. And for example, like sentiment, sums up a lot about the community that might be able to be broken down into other values. And I love what you're saying here. This is like a replaceable component because they're essentially doing their inflation through this fixed parameter, whereas we're using the bonding curve. So we can take so much of this that applies directly to our hatch, but then we can also take this one particular component that we are completely subbing out. So you get to see like the evolution of these approaches to hatches. It's really cool. So let's see. So sensitivity, is Santi in here? Because I think he
Yeah, I'm
was.
here, but I'm not really into the call. I was just basically listening.
Yeah, because I know you were really investigating sensitivity in the modeling. And I see this
Yeah, let me take.
sensitivity parameter in the one hive conviction voting. Um, wait, is this the conviction voting? Yeah, it is. Yeah. So I'm gonna compare this. I'm gonna jump into what we have for the common simulator. I'm just gonna look at that a little bit. So we have quite a few files here. Here's the config. I wonder if there's.
I think that it's better to go first with the conviction one, which also have many files in it.
Yeah.
No, the conviction, just conviction.
You mean this one here?
I think that you have it cloned, but it's in another folder. It's another repo.
So we have
Another one.
we have the one hive.
It's
Is it the one hive or is it? Are you talking about a different one?
this is the one hive, but there is another one that is from Block Science that is called Conviction.
Oh, this one.
Yes, this one.
Oh yeah, I think I did clone it, didn't I? Let me see.
Yeah, you have it.
Yeah.
I think that in order to go to the common simulator, this is the first one because it's based on this one.
Okay. Awesome.
And it has simulations for the bonding curve, simulations for conviction, and simulations for the hatch too. I think that if you open the next one, the hatch sim, for example,
Oh, nice.
you have here all the formulas. We are not using those formulas, okay? For the hatch, we are using an implementation that is not using these things. But it's nice to know that the vision on Common Stack is using these things.
So how do we move? Okay, so now when we're talking about the common simulator, is that moving towards the... So what is the difference between what's happening here and how we're doing it?
We are using the Aragon fundraising software, which is an independent development from Aragon Black. And this is like the design on how it's Michael's diagram and block science, the design of Common Stack, basically. But the Aragon Black team did an independent implementation. They were basing their job on Bancor formula, and they were just doing a simple hatch. So this is something that is interesting in order to maybe in future communities we use these things, but for now maybe we have to do just the we need simulations that are similar to the things that we already have implemented.
Oh, here, look at this. Okay, awesome bonding, a curated list of token bonding curve code and resources. I see Griff is a contributor. Okay. Oh, and there's a link to another repo called Awesome Decentralized Finance. This is pretty cool. So we have a list of simulations. So we have, oh yeah, the common stack, token bonding curve design, bonding playground.netlify. Let's see. Choose a bonding function. Cool. So this seems
Oh,
like...
that's pretty cool.
Yeah, yeah, I'm gonna link this. Seems like a great resource. See, we don't even need Griff in this call for him to show us where to look. Whoa.
What else we can? Yeah.
Sigmoidal token bonding curves. This is so awesome. I'm definitely going down this rabbit hole today. Common stack Genesis contracts. Let's see. So a bunch of DAO implementations, it looks like. And then the articles, deep dives on bonding curves. And, okay, Aragon's fundraising app. So, I'm curious about that Aragon Black that you were talking about, Sam, because I don't know anything about that.
Okay, it was an Aragon Flock team that mainly developed the Aragon fundraising, which is a template in which you have Bancor bonding curve, Bancor using the implementation of Bancor. And this is mostly the one that we are going to use for TEC. It has been adopted by other development teams, and OneHive is the last development team that has been, or Garden Swarm right now. We are inheriting that code, and we are doing some little changes, but not so big. It's mostly Aragon Black's work.
Okay, so I found this article in the Aragon Black documentation on the bonding curve.
Mm.
So, oh, what's
Yeah.
this GitHub? See what's on GitHub here. Oh,
Yeah.
fundraising.
Basically, what we remove is the tab functionality. The tab is something similar to what we have with the funding pool and the conviction voting. It was not yet there when they created Aragon Fundraising, and it looks that scheme is not so good. I think I never understood it. I think that it's completely outdated. The idea is that we have a market maker that allows you to buy and sell the token with one or many collaterals. You know, in our case, it means or burns TEC in exchange of DAI or XDAI or whatever. And once we have that, first, in order to initialize it, we have that pre-sale application that we are renaming to Hatch that allows everyone to have an initial bonding curve in an initial entry to the bonding curve with a fair distribution. Like everyone that wants to enter first, they receive the same amount of tokens. It's basically the hatch. This is the Bancor formula in Solidity. Very ugly, very powerful. And yeah, we have the tab that it is something like what Vitalik was calling a DAICO, in which the token holders can open and close the tab for the developers. This was implemented by Aragon Fundraising, but we are removing that part. It is the tab application, as you can see. Because we don't want that. We want just conviction voting, managing funds.
Are we going to use these contracts?
Yes, most of them. The Aragon Fundraising, right now we create marketplace controller, but it's just a controller. It's calling the other contracts. Then we have the market maker that it was batched Bancor market maker, but we removed the batching because it's easier to it was using a commit and reveal scheme, and you needed to wait during some blocks in order to do the transaction. You needed to do many transactions actually to buy or sell your tokens. This is because we wanted to prevent front running. Well, Aragon Black wanted to prevent front running, but we removed that part from OneHive because it was like it doesn't, it is not that important. You can do as Uniswap does, that you set a minimum that you want, and if you don't get that minimum, like 1% slippage, something like that. If there is somebody who front run you, it can only front run you 1%. And the advantage of that is that you don't need to do many transactions or even wait. So we removed some of the complexity there. And the other one is the the pre-sale that we are mostly using it, but with some restrictions. Well, we are calling it hatch, and we are adding the restriction that only CSTK tokens can contribute. Only CSTK token holders can contribute. And we are adding the impact hours in the hatch.
Cool.
Yeah.
So when it comes to the hatch in its entirety, is it mostly covered by these 4 sections, or is there a lot more to be considered as well?
When we are talking about the hatch, we are talking just about the what here it's called pre-sale. Because the bonding curve is the rest. It's the Bancor formula, Aragon fundraising, and the market maker. Those 3 are the bonding curve, but the hatch is just the pre-sale. And what we are doing with the hatch DAO is to use just that pre-sale application and don't use the bonding curve. We are separating the pre-sale from here.
This is amazing. This is so good to know. And so it sounds like we basically have a trail of modeling examples, but there's nothing that exactly matches these. Like there hasn't been specific modeling done for these components, so that's kind of the gap that is to be done. Okay. So we can
Because
Yeah, go ahead.
Zagram was using another formula for the bonding curve, which is using kappa or something like that. It's a different formula, and we don't have. I think that we don't have any simulation for the Aragon black bonding curve, and also the hatch that we are using with the vesting that we are using. It's not the same. Commodore Stack was thinking on a different formula for the vesting, but we are using the usual vesting approach in which you have a cliff and you have a vesting period, which are different things.
Okay.
Maybe in the future labs we can model the hatch.
Yeah, next week. So I think this was a really successful lab. I feel so much better that I have a very concrete understanding of like where we're coming from, what are all the resources that we can reference and learn from and get inspiration from. And then it's really about this. It's about taking these Aragon Black apps and understanding first of all what we're doing differently. And Sam, you just laid that out really nicely, and I think I'm gonna stay in here after the call and try to write some notes. And if anyone wants to, please, everyone, this could really be fleshed out a lot. If you actually want to write notes in here on any of these sections, just go ahead. You can just, if people aren't familiar with Notion, you just hit a plus, and that gives you a new block. So everything in Notion is a block, and you can like drag it and put it wherever. So I could write some notes here and say, let's consider all of the differences between Aragon Black, and the TEC hatch. And we can write some notes in here. Or these could evolve into forum posts as well if we want to show them to the community. Or we can make a forum post for this whole reference, actually, is probably a good idea. So I might do that, but someone might beat me to it. And yeah, this can flesh out, this can be sort of our base. And so I hope that everyone who attended this lab take some time throughout this week before next week's lab and come back to this and go where your nose, follow your nose, kind of like if one of these sections is really interesting to you, then please like go through and run the notebook or read one of the articles. Definitely open up this awesome bonding reference. This seems so cool. And I think this is Ben Schultz who teaches the CAD course. And then that's a good thing too. Yeah, take a look at that CAD course. It's normally $200, but you get it. The coupon code Block Science gets you it for free. So it's a really good resource. And then if you're more on the solidity end and smart contracts, definitely poke through these. This is so useful. This is awesome to have this.
Actually, we have it forked into one hive, and also we have a fork from. I mean, this is the main one, but in TEC we have one, and it's called Marketplace App instead of fundraising.
Oh, cool.
Marketplace App. It's the second one.
Oh, yeah. Awesome.
And it's upgraded.
Okay, so when it comes to modeling, Sem, do you think, because I saw this in one of the repos where they just had, like, in the actual implementation, I'd call this the implementation because we're dealing with smart contracts here. Would it make sense to have, like, a folder that is the simulations and then the Python files go in there? Or would it be better to have sort of like a central simulations repository?
I think that it's better to have it in another repository,
Mm-hmm.
as we have in the Hive conviction voting,
Mm.
CAD, or
Yep.
it could be simulations. Easy simulations would be nice.
Okay, so yeah, just TEC common/simulations. That would be awesome.
Yeah, that would be really nice.
Sweet. We can actually do that right now. In our, does anyone have questions in the last few minutes?
Uh, yeah, Sean, I guess in terms of so it sounds like we're kind of like riffing on like what projects are out there. But like if you're super new to CAD and stuff, like um, should I just dig into the Aragon Black apps and stuff, or like should I just go through like the conviction voting
Well,
thing? Because I guess I kind of this seems like a survey of stuff, but
there's
um,
yeah, so these are good references as you go, but start with, and I'll link this in here. There is the so CAD just recently released a course, or sorry, Block Science, I guess I should say. Actually, a group of organizations I think work together on it. But I linked it in the lab channel there, and you can use the code word Block Science to get in there to get into the course. And so for anyone who is really just first starting with CAD, yeah, start with the course. And then I think a good place to go from there is just running. Just like, you don't have to fully comprehend what's happening in these simulations, but they'll catch your eye. Like even me, I just randomly scrolled up and I see all these math equations. So I'm like, oh, okay, this is interesting. Maybe I'll read through these and see what they're saying, see if how much I can understand, and then see if I can start to map that into the code in my mind. And especially with the primer of going through the CAD course, I'm still going through it myself. I was trying to finish it before this lab, but I'm only about halfway through. But yeah, because it has all the very general core concepts of what every CAD situation is going to look like. And then you can go into the specific examples and be like, oh, okay, this is how they set up their parameters and their step functions and their configuration space. And
I would love to see you
I,
when you read that math, how you read it out loud. If you ever do, I would love it.
okay, let's try. So, augmented bonding curve mathematics, Hatch-Sale equations. So the initial raise is D0 die, or some people would say D naught, but D0 die, so that's the starting. Initial reserve is R0, which is 1 minus theta. So theta is some parameter times D0. So it's going to be a fraction. So the reserve is a fraction of your initial raise. Hatch sale price P0 is die per token, determines the initial supply S0, which is our raise over our price. So our supply is our raise amount of die. So it's total die raised divided by the price. Yep, because price is like DAI per token. So if you cancel those out, DAI is going to cancel out on the top and bottom, and you're just going to be left with your token. So supply is the number of tokens. So power function invariant shape is V of R and S, which are our supply and our reserve. And it's our supply K over our reserve. I'm not sure what the K indicates. Maybe kappa, or it might be some sort of time step. Price function.
It's called kappa, and it's a constant.
Oh, okay. Okay. So this is our invariant. Nice. So this is a key concept like from automated market makers like Uniswap. They fundamentally work on this invariant where we have some value that never changes. So if the supply changes, then the price has to change because the invariant is a function of the supply and the price. But in this case, it's the reserve and the supply. So we have this price function, which is the amount of DAI per token, P of R, and this is kappa R to the kappa minus 1 over. So then this is where I have to start sitting and scratching my head and thinking about it. But yeah, the fun part of math, when you do a lot of math, you start to get the ability to read it like a fluent language, and that is really fun. But it just takes practice, and it takes doing it a lot. But the best practice would be going through these and thinking logically if you can understand. Kind of like this one in my head, I was like, why is supply equal to your raise over your price? And then I kind of realized in my head the units here, the DAI cancels out, and we're just left with the token as the unit.
We can also the other repository is very much well documented with the one that finishes with cat is much better documented. It's the new one. Yeah, that one.
Yeah, this one.
It has a lot of documentation.
Yeah, this one.
And also there are the links on the Medium blogs are pretty cool.
Oh, here. Oh, this is great. Yeah, this is a good source.
Yeah, that's very good. That's the one that I will begin with.
Awesome. Okay, how's everyone feeling?
Definitely.
We're a bit over time. Maybe everyone's dropped off.
Yeah, I gotta take off, but thanks, Sean, and I'll see if I have some time to dig into this. But
yeah, and I'll see you next Friday.
Well, for the same thing?
Yeah, hopefully every
okay.
week. Yeah, actually next week will be the last one of the year, so tune in.
Sweet. Okay, sounds good. See y'all.
See you, Blair. Hey, thanks everyone for tuning in.
Hey guys.
See you next
Thanks,
week.
Sean.
Thank you.
Hey, Sean, can I ask you a question quick?
Yeah.
I still haven't been successful in setting up my environment. Could I just share my screen and you can maybe?
Yeah, let's do that.
It's let's see. Back in here. All right, this might be difficult for you to see. Can you see my screen here?
Yep.
Okay, so I have downloaded the environment and everything. I'm just trying to activate it at this point. But for some reason, it's not going through, just saying there's no file and directory.
Okay, so
maybe starting from the beginning might help you.
Just do an ls. Let's see where you're at.
Yeah.
So you have that activate here.
Right. It's not a directory then.
Okay, so you've done something. Yeah, you've done something. Oh yeah, because you moved into activate. I see up your commands up above that have like an arrow in them.
Yeah.
I think that might be where you messed up.
Okay. Yeah, I mean, like this is a variation that I found that I thought might work, but this is like how you're supposed to do it right here.
Yep, that looks right. Oh
so,
yes.
But,
so you have this. So let's just start from scratch. So you don't even have to delete these, but you might want to delete them later. But
Okay.
so first off, let's create a virtual environment.
Okay. So let's see, Python. Wait, no, I'm forgetting. I keep confusing Windows and Mac.
Okay, so I think it's going to be. You should just have this Just go back, and try. Yeah, and then tab complete. So you're gonna want to always tab complete when you can. That's gonna save you. And if you hit like tab and there's nothing.
Yeah, there's nothing.
Okay, wait. Then so what was the command you run? It might have been like Python-M.
I didn't run that, but I'm familiar with that one.
Wait, okay. Delete all this and hit Command R.
Okay. Like quit or?
No. Command R should bring up a reverse search.
Okay.
Does it?
No.
Nico, do you know? Is there a default reverse search in?
Like locate?
Reverse search. Because like on Linux, if you hit Control R, then it gives you a little search prompt to search through all your previous commands.
Oh, I mean, you could try that.
Control R.
Yeah. Oh, through your previous commands? Oh, there it is.
Yeah, you got it. Awesome.
Epic.
So just type in virtual.
Okay. There we go.
Yeah, run that. And then yeah, at the end, the name. So,
it's amateur hour here, guys. I'm sorry.
We've all been here.
Oh, it's all good.
Nico was here last week. Just kidding.
Yep.
/ or just.
I'm feeling like you maybe don't have it installed. Did you for sure create? Yeah, you did.
Wait,
Yeah, that's right.
Have you tried doing Python -m? Wait, do
No.
Python 3 -m?
Okay.
Venv. VE. Wait, just do
I think you got it installed. So yeah, take away the install there.
Okay.
Do VENV and then space, and then .env. There you go. So that's gonna make that virtual environment inside of that folder that you're in.
Awesome.
Yep. So to activate it, you just have to do source. Yeah. /
I've ran this a million times now.
Okay.
I think I have anyway. I guess it would be. I think this is my.
Yeah, you got it.
Almost.
Or wait, I think it's .n/bin.
Yeah, because so if you go up to get that back, just press up, and then delete the path there that starts with your home, the tilde.
Okay.
Just delete all.
Oh, fuck.
You can actually do Control U.
Yeah, Control U.
The whole thing.
Try Control U.
Okay. Yeah, I'm just gonna do that.
Okay, that's fine. Okay, so let's start again. Delete everything. Start fresh. So we had it. So it was like source. Okay, and then here, this is the path. So what you should know about paths is the dot represents your current path. So you can do like / and then .env.
Okay.
/bin. Yeah, and you always want to be using tab complete so go / and then hit an A and then hit tab. Yeah. So if it tab completes, you know you got it. So this is gonna work.
Awesome. Yay. Thank you guI'm
Awesome. You're so welcome.
Okay, well, I will come back to all of this now. I'm going to take a screen capture because this will, this is my moment of learning. Let's see.
Yeah, you're a Python warrior now.
Yeah, not quite, but I'm looking at it. I'll definitely go into that Notion and try and tinker around a little bit, see what I can figure out, and at least get set up for next week. And then last week I missed, so I'll have to go back and go through that tutorial.
Yeah, that was mostly on using GitHub, pushing and pulling from GitHub.
Okay.
So if that's
Yeah.
new to you, then yeah, check out the last week's lab and do a little bit of practice on that. And even going through these resources now this week is a good opportunity to practice with GitHub because you're going to want to clone these repos down to your local system.
Okay. Yeah, I mean, the first week I did do some cloning. I just honestly I can't remember the commands now, so I'll have to go through that again. And then I would like to do the CAD edu course. I think that'll be really helpful.
What you should really do, probably first, do all this stuff that you mentioned. Do the CAD course, but first thing that I recommend you can play around with is I put a link in the tech labs, and it's the fish shell. And
oh yeah,
yep. It's gonna make your life easier. Everything else will become easier.
Cool. Check that out.
Awesome.
Here, I'll show you my terminal real quick because I'm on Mac too.
Check this out.
And then you can see some of this terminal drip you can get. Here, so here's my terminal, which is we've got I think it's called like power level 10K. Wow, I'm a bit here. Look, when you have Git with it. Oh, I made a workspace. That's what happened.
Hey Nico, do you know Control L?
No, what's that? Oh, wow!
Yeah, dude.
I'm sorry. What happened?
So Control L clears the screen.
Okay, that's what I thought happened, but I thought something more significant might have happened. I was guessing which. No, there's no machine learning in this. I was gonna say, is it guessing like where he's trying to go?
Okay, if you want that, you can look up a tool called Auto Jump. It tracks every directory that you go into on your system and keeps a database of the most popular ones, and then you can just like jump between all the locations on your system super easily.
Whoa, nice. Okay, yeah, that's pretty much it. And then it keeps track of your Git too, which is kind of nifty. So, yeah.
It all starts with fish shell.
Yes.
Okay, guys.
All right, I gotta jump, but thank you so much.
Yeah, awesome.
I'll definitely be on next week, so I'm excited about this.
Awesome, sounds good. Okay, have a good week, you guys. Thanks, everyone.
Yeah. See you soon.
Bye.
Bye. See you, Tonga. I like your